All right, so I'm going to go through a lot with this. Okay, so please let me know if something doesn't make sense. You're also in groups for a reason, right? So that you have something to quickly turn to and be like, what the heck just happened? And they can hopefully show you if you missed it, but also let me know. So the first thing is obviously we want to put in y equals. We know that we're in the right mode. We're in radians. Okay. The second thing is that this has a restricted domain. You have to pay attention to domains in the class. Okay. So especially with the calculator, you're going to go crazy trying to find things if you don't adhere to the domain. So I'm going to go into window and I'm going to do 0 to pi over 3 to start. Okay. So I know that I'm going to have 0 to pi over 3. So if I press graph now, this is the visual of what I have. That's not a very good graph for me when I look at this. So one of the things that you can do is that you can make your calculator fit for you a good range if you define the domain, provided there's no asymptote there. Okay, as long as there's no vertical asymptote and the graph doesn't go crazy as we approach it. If I press zoom fit, okay, which is zoom 0, so you can press 0 or you can go all the way down. As long as I define my x values, my domain, and I press zoom fit, okay, it'll make a nice graph for me in terms of the y value. So that's the original function. Whether or not I needed that, that's just one thing that we can do in order to look at that. All right, so I need the derivative value of pi over 2. Okay, I know since there's multiple problems with this that I'm going to need y2 to be the derivative anyway. So I'm going to go through the derivative piece again as one way to find it. So I'm going to calculate, okay, the derivative, okay, and then so math 8, and then vars, y vars, function, y1, comma x, comma x. So I'm finding the derivative for all values, okay. When I look at the first one, I need a pi over 2. I can leave it like this. I'm going to go into my table, okay. I'm going to punch in pi over 2. I hit enter. So if I disabled y1, it won't show up here, but that's the y value associated with pi over 2. And here's the y value associated with the derivative of pi over 2. So I copy those down as negative 2.537 or negative 2.538 because that's rounded or truncated. I'm done. So that should take a matter of seconds. Questions on that step? Yes.
Why does it not work when you put it into the value?
So if you have your functions graphed, okay, I could calculate a value. You need to make sure you're on the right graph, okay? I was going to graph it. Now my window doesn't look very good. The problem is I think it doesn't know which function you're in. So I guess if you turn off the first one, okay, I don't do it this way, so I'm not entirely sure. But if I turn off the first one, and now if I press value, it should come out to be the same thing. So go to, so it has an issue, probably because it doesn't see it. I don't know, zoom 0 with this graph. Maybe it doesn't do it on the derivative graph. I don't know. I don't do it that way. So, all right, see how it's going too slow? Press the on button, it'll stop it from graphing. Okay, this is a little trick. So it's taking too long, and you don't want to wait there for it. If you press the on button, it'll stop it midstream. Okay, go to window. Okay, down here where it says XRes, change that to like a 4. Okay, and then graph again. Okay? We'll go much quicker. Okay? So you can pause it by pressing on, and then if you go to window, XRes can be changed to a higher number like 3 or 4. It's not going to change your answers. It's just going to graph less visually appealing if you put that number up too high. So that's what we're looking at. So I don't know. Would that work out? I have no idea. So pi over 3. Would it work? Oh, pi over 2. Sorry. Pi over 2. No, still an issue. I guess you can't do it on that. I never try to do it that way for the derivative graph. So that's what we have there. So I would go into your table as the easiest way to do it is evaluate there. All right, so the second one, where is the derivative 1/4? We're not going to do guess and check until we get 1/4. We're going to graph 1/4 with it, okay? And now when we graph, we're going to see this line with the curve. We want the intersection. So second trace, we want intersect, okay? First curve, you're already on the curve. It says the derivative up top. Hit enter. Second curve, it asks for it already switches it for you. It's right there. Hit enter. I don't know why they programmed this, but they asked for guess. Hit enter. So there's my answer, 0.531. Okay, rounded or truncated, it's the same. I write that down. Okay. Before I go on to part B, any questions with that? Okay. So yeah,
Isn't it on the other side too? Like, wouldn't it also be negative?
it would not. because our domain is from 0 to pi over 3.
Oh, yep.
Okay? So part B, find f of x where f prime is equal to 1/4. Well, f prime equals 1/4 at 0.531. But there's more to it than that. So you have to know how to take a value that you found and store it and use it. Okay? And this is an important skill that you need in the class. So once you calculate something on this screen here through the graphical analysis, okay? So through the graphing screen, you press second mode to quit out into the calculation screen, okay? Then you press the STO button, and it's saying answer with an arrow. It's saying, what do you want to do with this answer? I want to store it. You can choose any letter you want, okay? So I would use alpha and let's say R for rule. Where's R? There we go. So alpha R. So now R is stored as 0.531260. The entire number is stored for me. So if I want to use that number, I just call up R, and then I would say, well, I want to add 2 to it because I don't know how to do that. Okay, so then I get that number. Okay, why is that important? Because now I can use that number in its entirety instead of a truncated value. Okay, so if I want the original function at that x value that I stored, I can go into y equals, right? So I have my original function, go into my table, call back up my stored value, hit enter, and I see here is the value that I get at the original function at that point, 0.330 or 0.331. Okay, so very similar. And then I get, the y2, which makes sense because that's the value we found in the derivative there. Okay, so that's the value that we're talking about. Okay, so to recap, okay, you did some calculation in the graphing screen. So if I have all of them, I don't like having all of them on here because it gets messy. Just the ones I need. So if I was finding an intersection, second trace, intersect, let's just say, so I calculate this thing, it gives me the answer, and great, but I need this in its entirety because I can't round within the problem. Quit out of the screen to get back to the calculation screen, STO, and choose a letter. So let's say I want it to be A. So now A will be that until I overwrite it, until I write something else to store as A, okay? And then I can pull it back in wherever I want. All right, question 3, the equation of a tangent line at 1/2. Well, if I want a tangent line instantly, I should be thinking in my mind, I need 2 pieces of information. What are the 2 pieces of information I need if I need a tangent line? What are we going to need? Masa, what do we need if we need a tangent line? A point and the slope. Exactly right. Do we have anything to do with the point yet? So therefore, we need also what for the ordered pair? We need the slope and what else? We need what? I'm sorry. We don't need the y-intercept for it. So when we write an equation of a tangent line, we need 2 pieces of information. We need the point and the slope. We don't have the full point. We only have the x value. We need the y value associated with it. Okay. So if you're going to do this, this should take you 2 seconds. Okay. If my function and its derivative is in y1 and y2, go to my table. Okay. Put in 1/2 or 0.5. I have everything I need. I'm essentially done. If I have a point in the slope, what makes most sense to use what? What format? Point slope. Why would you do anything else? Use point slope. Okay. So whatever those numbers are, I don't remember what they are. So if I was going to use point slope, well, I have everything I need right here. So I have y minus the y value. The y value was in y1. Okay, so 0.321 or 0.322. Okay, equals my slope, which comes from my derivative, which is 0.323 or 0.324 because of rounding. And then x minus the x value. The x value was 1/2. Done. I don't need to do anything else. That problem should take you 20 seconds. Okay, if you know what you need and you know how to find it. Okay. Yep. What part?
Question 3.
Okay. What do you need if you need a tangent line? Right. So both of those come from, the easiest way to find that is if you have in here your function and the derivative. All I need to do is evaluate in the table the x value in which I need. Here's the y value associated with it. And here's the slope associated with it because y2 is my derivative. So then I have a point in the slope. I have the y value, which is 0.321, right? And I have my derivative at that point, which was going to be whatever it was, 0.323. So I just put in point sold. Okay. Find the value of the derivative when f of x equals 1/3. So I need to know when the original function is 1/3. So I'm going to disable my derivative for a second. I'm going to set this equal to 1/3. I still have the domain. And just see if I can see it. So something a little fishy going on there. So I might zoom in just to see what's going on. So zoom, option 2, bring the cursor to where I want. This should be something you've done before. Ooh, it's looking like we have some stuff going on here. So zoom 0 maybe in the window that I had. Makes it a little bit easier to see. I have 2 intersection points, so I would find both of these intersections, store them, and then put them into the derivative function in the table, and those would be my values. So second trace, intersect. Okay. So the first one is point, whatever that is. Store alpha A. Okay. So now A is 0.542. Calculate and intersect. Go to the other one. I'm over towards it. This should be nothing new. Okay. I'm going to quit out of the screen. I'm going to store it as alpha B. Okay. So now I have A and B are the x values that I want. So find the value of the derivative at those points. So when I go into y equals, I want to know my derivative. Right. So when I go back to my table, that's my y2 column. I'll call up A. I'll call up B. And those are my values. 0.2 repeating and negative 0.259. Find where the derivative is equal to 0 on that interval. So I'm going to graph the derivative graph. A window 0, 2 pi over 3. And then I'm going to do zoom 0 because the window range was all messed up. So there's my derivative graph. I want to know where it crosses the x-axis. I am not finding an intersection. Okay? There is no line for it to intersect. The x-axis is not a line. Okay? It's imaginary. It doesn't have anything to do with it. If you want to graph y equals 0, you can do this. Or your calculator would need to find the 0. It's not finding intersections. When you find a 0, like in your summer work, to the left of it, hit enter. To the right of it, hit enter. Okay? Hit enter for guess. There's the value that I need. Okay? It's 0.618. Okay? It's 0.618, and that's the value that we have. And that's what it's going to be. Okay. So that's a lot. So there's a lot going on with the calculator. I'd say probably 85% of it should be reviewed from Algebra 2 and Pre-Calculus. Okay? Maybe there's some little tricks in there that you didn't do before. Maybe you did. I don't know. But finding intersections, finding zeros, changing window ranges, those should all be things that you've done in previous courses. Okay? Maybe storing a value. I don't know if you ever stored values before. Do you guys store values in previous class? Okay, so that's new. Other than that, the derivative we talked about before, we did it again today. What is an area that I can clear up for anyone with this stuff? Any questions for the calculator? So if you're working with the calculator, you don't know what you need. That's the first thing. You don't know what you need. That's going to be the biggest hindrance. If you know what you need, you got to figure out how to find it quickly. Yes.